Welcome to the SMPTE New York July section meeting. Tonight's topic is Media over IP ecosystem. We have three fantastic guests for you tonight. We have a good presentation this evening. We have a catch up on SMPTE 2110. First, I'd like to make a few announcements, and I like to thank our sponsors for helping us financially and with their support through the through our Friends with SMPTE initiative. We will be starting a new Friends with SMPTE initiative fairly soon. I also want to encourage anyone who is not a member to join. You can do that by going to the SMPTE.org individual membership website and sign up to become a member of SMPTE. All the benefits at each one of the levels is shown there. And if you're a student, please feel free and come on in. The price of student membership is very low, as you can see here. So please don't hesitate to sign up to become a SMPTE member. Also, sadly, I want to take a moment and acknowledge the passing of Bob Ross. Bob Ross was the Senior VP of East Coast Operations and Engineering at CBS. And on August 18th, there will be a celebration of his life at the CBS Broadcast Center at 524 West 57th Street, New York. And if you want, if you wish to attend, please confirm your attendance with Olivia Ross. Her email address is oliviafross@netscape.net. So please email her. I will place that email in the chat for everyone to see. Just be advised that according to CBS's COVID policy, you will need to wear a mask, and you will also have to provide proof of vaccination. So on to, without any further ado, on to our presentation this evening. We do ask that you place questions in the Q&A to submit any question to the presenters, and we will be curating those questions, and they will get answered in due time. So without further ado, I'm going to pass it on to Mike Strein, who will moderate the meeting tonight. Take it away, Mike.
Thanks, Ed. I just want to echo that point about Bob Ross. Bob was a great friend to SMPTE. He's an icon in this industry, and he's really be missed. First, I want to thank Joe LaGrasso and Tom Morrow. They're my co-producers for this event. But also for Q&A, we encourage you. It's kind of a free-form thing. So if you have questions, just put them in the chat, and we'll get to them hopefully during the event, not have to wait till the end. So we'd love to be interrupted. We kind of want to make this a flowing presentation. There's not a lot of slides here. It's sort of more like the three of us kind of asking questions and answering them, and going through somewhat of what we think about this ecosystem that we're going to review today. The genesis of this is that quite often in June, although it's July now, of every year, we do kind of a review of where 2110 is, and 2110 being the standard for media over IP developed by SMPTE. But we wanted to take in a little bit of a different direction this time. And that said, we don't want to just focus on what the physical layer and the standard is for 2110, but it's more the ecosystem, right? So it's all kind of what goes around this and what makes it work. For people that have lived in Sdi and even analog environments, you've all worked on routers, you've put things in, you've had to manage it. And there's a control system around that. And there's a lot more things that work around 2110 to make it all work. And, you know, there are other industry organizations and bodies out there that have tried to make 2110 fit into that ecosystem. And there are also the groups we're going to talk about here a little bit, and they've come out with, you know, specifications around this. And, you know, maybe we'll talk a little bit about what the difference is between a standard and a specification. And, you know, the three of us, myself, Karl, and John, all SMPTE fellows, by the way, are, you know, pretty much affiliated with a lot of these types of organizations. And a lot of what we do as in our careers is trying to sometimes translate those things into working environments. So that's my intro. We'll, you know, John and Karl, we want to pop up on screen and we can, you know, talk about you guys quick and we can kick this thing off. All right, there's our first slide. So you are here. Again, like I said, this is free form. So if it sounds like we're not exactly sure where we're going, that's probably a little bit true. But I think what we wanted to talk about is the system, right? What works around these things, what makes everything work. John, as part of his career, was you were the secretary, right, John, for the entire 2110 standard. So
the editor. So
the editor,
yeah.
That's it. And it took multiple years. And I was on that reflector, and I think Karl was on that reflector too. And there were just thousands of emails going back and forth, and all the different aspects of it.
A lot of times, it was an exercise just in keeping the ball on the other side of the net.
Yeah.
But you know, it's. I think my training ground when I first met Mike, it was working on ATSC1, yeah. And that was really only 6 companies plus some broadcasters. This drafting group that made 2110 at the peak, I think there were 230 members of the drafting group, and generally at a meeting 70 or 80 would show up and about 30 would have opinions.
Yeah, we all had opinions. 30 were very expressive about theirs.
Yes.
Had no choice.
Yeah, exactly. So why don't you put up that one slide, just 2110 and all the aspects of
Sure. I mean,
yeah,
this is great to look back at, because these were done and 2017 was 5 years ago. It's
Yep.
shocking that it is, but it is, and a lot's happened since then.
Yeah, exactly. And a lot of these things have been deployed. Karl and has probably deployed a number of these through his company. Joe LaGrasso even has a company named 2110 Solutions. Look at that. So obviously this is pretty prevalent out in the media environment now. But all these are different parts of what make that a standard. So for all the physical carrier mechanism for sending those media signals around. But what we wanted to talk about today was more what are the things around it that make it work right? How does tally get accomplished? How do these signals connect to one another? I think one analogy we've talked about a little bit is when you have the technician who needs to take a camera and work on it on the bench. And in SDI or an analog, you took the output of the camera and you fed it to a monitor, and maybe you looked at it on a scope or something. Well, it's a little different than that in 2110. It's not just a direct IP connection. There's all sorts of things that happen, and I think we wanted to talk about that a bit. So,
yeah, it's definitely we had to make some choices, right? Because the decision to move to an IP ecosystem does mean that there's some configuration and things that has to be done for things to work. It's not just dumb equipment connected by dumb wires. Now it's things in a switched environment, and there have to be addresses, there have to be some organization to it. And that really helps when you're in a large system. But in a small system, of course, like you say, it's not like just self-assembling Tinker Toys. So that's a trade-off that we made as an industry, was to make the easy case a little harder in order to make the really hard case be manageable.
John,
I think John, go ahead. Sorry, Karl.
And John, I think the important part of that is we used understood IT-based technologies with firm open standards and directions and things from the IEEE and IETF and others like that in order to make this happen. I don't know whether that was necessarily a smart thing to do, is making an assumption that every IT person would quickly grasp all of this, because there's a middle part of this that you show here called the node, the media node, that has a set of complexities that are unlike others in any type of IT instruction or implementation.
Yeah, and before we move into this, I just want to step back a bit. What were the reasons to move to an IP environment? And typically that reason was scale, right? If you were in an SDI or an analog environment, you kind of maxed out at around 1152 square for your inputs and outputs. And beyond that, there was a lot of fan outs, and it just became so cumbersome. Now, that type of environment, you could still manage with spreadsheets, keep track of all your inputs and outputs and what the names are and the sources and all that. But when you get bigger than that, and now let's say you can have a router to cover your whole plant, and it can be thousands of inputs and thousands of outputs. And these don't just have a source anymore. You can have multiple sources, because you're going to have multiple multicast addresses that come out. And, video and each of those standards you saw in 2110 has a different multicast address. And then there's a management address. So there's all these things that need to be managed. And this is the kind of system an example of something that goes around it that helps you manage that system. So why don't we walk through this quickly?
Yeah, sure. And this diagram is shamelessly stolen from the JTNM TR1001 document, which, was an attempt to define when a, media node, which is a thing that does something like either a throwdown brick or something big like a production switcher, when it wakes up out of the box, what environment can it expect to find around it? And this was important to the vendors to have some document like that, and it was helpful to end users as well. The media node, when it wakes up, the idea is that it expects to be able to connect to a control network. Just like you take your laptop to a hotel, you plug it into the Ethernet or you connect to the Wi-Fi. It's a similar idea. You're connecting to a network, and on that network, the first thing you do is ask for an address, and that's what DHCP is. It's the way the hotel gives you an address, and in media networks, it's the way that the network gives you an address.
Now, if you don't have DHCP, which you can do, you have to manage, typically in a spreadsheet, all those static IP addresses.
Right, and we have a lot of customers who swear by their spreadsheet. You'll peel it out of their cold, dead fingers, and that's fine. Like, God bless you. You want a spreadsheet with a list that you made that, the second digit and the address has to do with what floor of the building it's on. You can do that, and people do.
Yes, and all you have to do is make one mistake in that spreadsheet, and you can screw up your entire building. But
right, I think
we'll stay away from that.
Right, but to Karl's question of whether these things were a good idea, I believe long-term, they're all good ideas. But it's the getting there. It's the steps of us as people learning stuff, learning how this all works. And I don't know, I was in some conference, and the statement somebody made was, the slowest evolving part of the television ecosystem is the people. And that's us, right? So the these things like DHCP, they just work so well that you stopped noticing them years ago, right? These are dusty documents from the 90s. They just work. The same thing with DNS. How does your computer know where Google is? Well, it looks it up in DNS. You look up google.com, and it gives you a whole whack of ways to find Google, and your computer knows how to pick the right one. Again, not new technology, not even recent technology. It's really, the only changes that have been made to DNS in the last 10 years have had to do with security of how the entries get into it.
Kind of what we're talking about here is taking best practices from the IT industry and applying them in broadcast, right? And that's what those two really are.
Yeah, they are not just best practices, they're kind of the only practice.
Standard practices, yeah.
And, then, of course, those are both built around the idea of, how does unicast regular IP work? The things that are a little more unique to our television ecosystem have to do with the heavy use of multicast and how devices get configured for multicast addresses. And that's what, this ISO 4 is about, is a device wakes up, it gets an address. That's the easy part. Then it goes and it looks up in DNS how to find a registry where it registers itself and it says, hey, I'm an AJA IPG10G, and it doesn't know what monitor it lives on the back of, but at least it knows that it's an AJA box, right? And then, or a ROS box or whoever's box. So then you as a broadcast controller can say, hey, show me what's new in the network. Oh, look, that thing I just hung up is out there. Let me give it a name. That's monitor 37. And boom, now it's part of a system and it's usable. That's the idea.
So let's talk about that. Let's introduce ISO 4. ISO 4 is a specification by AMWA, which defines the discovery and registration of these media nodes. So
Yep.
it's essentially it's not a standard, but it's kind of a best practice on how to do this sort of thing, right?
Yeah.
And if media nodes can now put this into their code when it wakes up on a network, it can find the ISO 4 and the registration server, so it can go see where it is and then talk back to the broadcast controller. So that's kind of what that ISO 4 stands for. And as we go through this, we're going to talk about, industry organizations that are involved in this. And AMWA is one of them. And that's what we're talking about here.
Yeah, and I think early on, Rich Friedel, God bless him, he early on started this idea of a joint task force on network media. And the joint task force was really between VSF, AMWA, SMPTE, Ames came later, AES, and whoever else was interested. And that was sort of the core groups were VSF, AMWA, and SMPTE. And we realized early on that there was enough work to do and enough possibility for duplication among those groups that we ought to be organized. We ought to say, okay, who's going to work on which part? And so it was really in that JTNM, management group that decisions got made about, okay, SMPTE's going to work on these parts, and AMWA is going to work on these parts, and the IETF worked on a part, and the, EBU worked on a couple of things. And so that was how we divided the problem so that the work would get done in parallel, because in SMPTE, it's a big, complicated machine to move through SMPTE, and it tends to focus on one thing at a time. So in the drafting group, we focused on -10, then 20, then 21, then 30 somewhere in there, and then 40. And that's fine because we got them all done. But in the parallel, we accomplished other things. So in parallel, AMWA worked out the big ones here, 4 and 5. So
and again, the difference, SMPTE is a registered standards organization. So it can reference back to, a government standard making body. All the practices involved in making that standard are referenced and registered. AMWA, the Advanced Media Workflow Association, is an industry consortium of people who care, right?
Yeah, it's a trade association,
yeah.
Sort of the technical term. And as is the Video Services Forum, and honestly, there's a lot of trade associations, right? And they have different rules, but mainly it's to be the ISO accredited standards with a capital S organization, ISO actually allocates. So SMPTE is not just a standards organization. SMPTE is the designated standards organization for the motion picture and television industry. And that's a big deal. And there's good points to that, and there's challenges that come with that as well, because it defines a lot of process things that sometimes feel more rigorous than maybe you wish.
And SMPTE is not about necessarily the exact ways to implement anything. It's really a group of standards that basically says if you are a manufacturer and you follow all of the rules as designated in the standards, that you're going to have an interoperable capabilities of your system without fail. The other parts, such as what AMWA and others do, is really help aids in making sure that your concepts for implementation are sort of agreed to and addressed appropriately across the entire industry, not just manufacturers.
Right, but I think people get too excited about this distinction because, these specifications in AMWA are perfectly valid. This designation of stable that like ISO 4 and 5 and 8 are designated as stable is really a pinky swear from AMWA that, yeah, this one's not changing. And if we make any tweaks to it, they'll be backward compatible. That's kind of what that stable thing means. And if you look at an organization like the IETF, and you say, are they the designated standards body for the internet? You might think they are, but they're a little bit funnier than that. So it's, this is kind of a subtle distinction compared to all the real problems in the world.
Yeah, the IETF they're all RFCs, recommended.
They're request for comments.
Request for, yeah, there you go. Thank you.
And there's probably a lot of those.
Yeah. Just like every LinkedIn post is a request for comments, right?
Yeah.
So, in the AMWA, this 4 and 5 got done in parallel with the 2110 development. They came out, around the same time, maybe, months later. And they were really tailored around 2110. So in the 2110 spec, it says, devices should expose this stuff on their management interface. And then there's a footnote in the newest version that hasn't published yet that says, by the way, ISO 4 and 5 is the way most people do that.
Exactly.
But in any case, they work like that. Those are really these things that live out there in the network that the media node wakes up, it registers itself into the ISO 4 registry, and then it waits for instructions. And those instructions, like what stream should I eat, what multicast address should I transmit on, those come through ISO 5.
Right. And that can, in some instances, be part of the broadcast controller, or it can work in parallel with the broadcast controller.
Right. I mean, most broadcast controllers that support NMOS, and I'll go on a limb and say all the ones I know of, they implement ISO 4 and 5 in the broadcast controller just because, they need it to be there. And so it's but they implement it in a standard way. There's a test plan. You have to pass it. You have to prove it works.
Right. There's obviously more to this diagram than just what we're showing here. There's network control and there's all sorts of things inside those cloudy little network diagrams, but we're not going to go into an enormous amount of detail here, but look at some of the systems around it.
Yeah, we love to draw the network as a cloud because understanding what's really going on there is a different topic.
Yeah, but I think a distinction you just made a little bit ago, John, how multicast is a necessary part of 2110 because it allows the same operation that would happen in an SDI or analog router, the fan out of many signals to ripple through a routing system, as opposed to unicast connections where it would immediately saturate the bandwidth where you had to, send one to many. You would have a separate connection from source to destination constantly. So the multicast is a complex topic for a switch because the bandwidth has to be managed. And some of what happens in those broadcast controllers is they have to manage the flows and what's happening so you don't saturate a switch. So that's kind of all working together with these parts and pieces here to make this system work.
One analogy to multicast is similar to what we do with SDI, where usually the first stop out of the device is a DA. And every one of the streams or the signals that come out of every one of the ports on that DA, the B and C connection, effectively is a broadcast type connection, not a multicast connection, because you generally don't go in and turn a port on a DA off and leave others on, or vice versa.
Exactly. So as you said, John, there's a management address that comes up, and that allows the system to know what the name of the device is, what the media node's capable of, right? And then there's a multicast address, which now, if it's video and multiple channels of audio and maybe metadata, these may all have separate multicast addresses. So that's where it gets complex. And imagine thousands of sources with thousands of multicast addresses.
Tens of thousands.
Yeah, tens of thousands.
And it's complicated if you're managing it with a pencil, but don't manage it with a pencil. I mean, that's really the lesson that we've learned as we build bigger and bigger systems, is that the bounds of what makes sense to do in a spreadsheet versus what's managed with a tool. And, sometimes the tool outloads to a spreadsheet and you can go mess with it. But ultimately, one of the challenges in these bigger and bigger systems becomes configuration management. How do I store, what is the truth? How do I store the truth? Where is the truth? And what is a copy that might have been changed by somebody? And,
Great
you
point.
went
Great
through
point.
this with drawings, right? Drawings had version control, and there was a master set in somebody's desk that hadn't been looked at in years, and there was a working copy on the wall, and, so forth. There's tools for this in the world that a good practice in television would be to use them.
Yeah, exactly. Because you're going to quickly realize that AutoCAD and the typical packages we had for installations and drawing physical connections is good for when you first wire up your building. After that, God knows where those signals are going. So they may be traversing the network in various different ways. So you need these other tools, IPAM, IP address management, and other such things like that to discern where things are and what they're doing. And sources of truth are important. If you make a change, how do you have a snapshot of your system? How do you revert back? How do you go forward? All these sorts of things.
Yep. No, it's a big part of managing the totality of the system, right? Is that, now don't be frightened by all this. Like a lot of these comments are really about the mega projects, the Hudson Yardses or the NFLs, the really big projects. If you're talking about like a mid-sized system, a newsroom rebuild for a small, for medium market, that kind of thing, those systems are modest. Those systems, you can do it all on a spreadsheet. You can install it all in a couple of days, get it going. They're reasonable systems, right? And we knock those out every day. I mean, there's lots of small systems and medium systems where the normal, I do a spreadsheet and the vendor comes in and commissions the router database and the customer knows how to make small changes to it. That all works fine for small and medium projects. It's really the mega projects where the traditional ways show their weak points.
Yeah. And if you go back to that little scenario we threw out at the beginning with the technician who has the camera, pops the camera on the bench. Yeah. No. The technician throws the camera on the bench and connects it up to the monitor. Well, now the system recognizes the camera. It knows what it is. It knows what it's capable of. And, with your, your same dial-up type routing control panel, you route it into that monitor display and you can look at it. It's just a different way of accomplishing what you've done for forever.
Right. And I think one of the best practices that comes into play is that if you have a large system with a lot of, a broadcast controller with a big database and media networks and media nodes and so forth, it's really, really important on the big projects to plan on having a sandbox. And the sandbox means you have a copy of the broadcast controller that you run that's not on the live system, and some switches that are not on the live system, and some example devices that are not on the live system. And typically, like your technician in the media, who wants to adjust a camera, he goes and plugs that camera into a jumper of the sandbox system that's in the maintenance shop. And that way, he's not interrupting the main system, because he might update the firmware on the camera or do something else too that might actually want to get checked. And the thing you have to really remember is that every one of these pieces in this picture has a software release twice a year that you kind of want to install. And you need to be in a position to check that those releases work against your other vendors correctly before you roll it out into the big system. So having that sandbox and the ability to deploy things to the sandbox and make sure they work with all your other integrations before you roll them out to the big system, that's just a success factor.
Yeah, absolutely. I think at some point during tonight we'll talk about security. And John's right. You want to do those updates because you may be patching security flaws, and you're going to need to do that as a practice.
Another part of that whole model is that most broadcast controllers have an A and a B, or one that's assigned to the red network and the other one that's assigned to the blue network or amber network per the diagram we've got down here. the practicality behind that is that you need to develop a means to do appropriate upgrades, particularly to switches or broadcast controllers that leverage the fact that you can still run the system on one network. You're a little bit vulnerable from the fact that if that network crashes, getting over to the other one might cause a problem, but that's very, very rare, if ever, that happens, except maybe in some very early implementations that you may have heard about, even back to the days of 2022-6 before 2110. But you know, the whole major part about the rationale behind 2110 in a network-centric environment heavily leverages this multicast concept, but it also leverages the flexibility, the idea to do things that you couldn't do on an SDI router when you went from 1151 to 1152 and somebody says to you, we're going to stand up a new studio, but you have to have it ready next week, and all the hair fell out of everybody's head at the same time.
Yeah, great point, Karl. The SDI and analog routers, you would typically put in things like redundant matrix cards to back up your system, and it's different now. And we have a color scheme we talk about, and that's why blue is up there in amber, and there's red and blue networks, and then there's purplish networks, and there's all sorts of things. But essentially, these are providing resilient and/or redundant paths for a signal to get from source to destination.
Yeah, and it's actually better than the SDI case in a lot of ways, because you know, the SDI routers, I mean, if you had to upgrade the firmware on, say, the crosspoint cards in your router, something like that, thankfully it was rare, because it was, you know, it was a maintenance interval for the big thing, right? But the control systems, you know, the broadcast controller, or what you used to call the routing control system, you know, we've been upgrading those on air for years, right? You have main and protect, and most, you know, every vendor that makes those has a way that you upgrade the backup one and you push over to it, and then you can update the primary if you like how it went. And you know, that doing that on air is pretty well established turf as an industry. What's new is that the routing system itself, the fabric, has an A and a B, and so you can actually run, you know, your whole plant. Every signal can be correctly protected, and so, you know, you might think of it as, oh, well, it's protecting against a broken fiber, a dirty fiber, and, you know, failed SFB, all those things. That's true. But it also protects against the failure of a switch, or more realistically, the need to upgrade the software on a switch. Because as you build these bigger and bigger plants, getting a 15 or 20 minute outage interval for the entire plant, yeah, right. Forget about it.
Yeah, exactly. And if your whole reason to go to IP was scale, and now maybe your entire plant is on this router, and trying to get any downtime now is near impossible. So yeah, these multiple paths allow you to operate. Now, it's also key to recognize that if you had a red and a blue network, let's say, it doesn't mean that your signal is only traversing red or only traversing blue. It's traversing whatever is available, and it's taken the appropriate path to get there. And there are things such as PTP, which we have there, timing mechanisms to make sure the exact latency of those paths are exactly the same. And I don't know if we're going to talk about -7 at some point, but you know, you can have multiple paths to get there, and -7 will make sure they're lined up and absolutely correct.
Right. In fact, most systems that are deployed have two networks like we drew here and use -7. So literally copies of the same data go through both networks. They have sequence numbers. The sequence numbers, you match them up at the far end. The delays might be different. You know, there might be more leafs or a bigger chain or a different set of spines in one network than the other. There was one broadcaster in Europe who famously built red with Arista and amber with Cisco, and they were different. And, you know, God bless them, it worked fine, but it did take a lot of head scratching of everyone involved to, you know, get the whole thing working. Not because of any real reason, just, you know, they were each just, the commands you typed on one were different than the commands you typed on the other. All to say that this having this failure protection, this really works. I mean, I know a major, you know, a broadcaster who had one of their switches fail, like, you know, the power supply failed or something during their show. They were doing their live show and this and that, and The only thing that didn't work perfectly was that they had one editor off in an edit room where the fiber to one of the switches had been broken for weeks and they hadn't bothered to fix it. And so that one edit station was offline because the switch that it was attached to had failed. Everything else, the multi-viewers, the switcher, the cameras, everything else was perfectly happy. And they got through the show, and in post-show, the editor complained that his edit station stopped working, and that's when they noticed. Now, you might wonder why they hadn't noticed sooner, but that's why they noticed that one of their switches was down.
Exactly. Just going to take a minute here. If anybody has any questions, feel free to throw them in the Q&A window. I know we're talking around and going in various different directions, and if it's too deep or it's not deep enough, we welcome all comments.
Yeah, you steer, or yeah, you guys steer. We'll just keep rowing.
Yeah, exactly. I like that.
All right. Let's see.
Good. You want to go back to the AMWA standards and we can walk through a couple more of those, maybe?
Yeah, sure. Talk them through. So 4 and 5 we hit. 4 is how do I find my stuff, and 5 is how do I tell my stuff, how do I tell receivers what to eat? How do I tell senders what address to send on? That's what 4 and 5 do. They're not that glorious.
They're simple and universally accepted by almost everyone that's building a system nowadays. There are a few exceptions where there are beliefs or philosophies by a particular manufacturer or provider of services that has opinions that include things like, we've got a better way of doing it. But I think in general, the whole ISO 4 and 05, those two interface specifications, as they're formally known, are consistent across almost every system, at least that we've run into so far or have watched develop. You may have heard, we will get there when the rest of the industry puts a demand on it, and that is the case in some of the other specifications. But the performance of that particular IS, take ISO 7 and so forth, and how you go about doing that leaves open flexibility if you follow those rules to go and take that approach and apply it to other solution sets within the broadcast environment, such as the tally system or the GPIO systems and things like that. People have asked, how do we do a GPIO in an IP world? And that's the methodology from the signaling perspective. And we
go ahead, finish, Karl.
I was just going to say, and things like this have continual feedback and input from particularly from those users or those integration engineers that have gone through this, so that we stay current, we stay consistent, and then we identify issues that might not have been ever discovered unless you stood up a large system in an interoperability perspective or in a lab, which is pretty rare, because to have all the hardware sitting in a lab somewhere just waiting to be tested is probably not a real practical use of time and money.
Yeah.
Yeah, and I'll say, our experience right now, and I think Karl's experience is similar, is that when we go and install a project, there'll usually be some new widget or some widget that we haven't seen a version of before. And it says, hey, it speaks NMOS. And, early on, like 2 years ago, we'd say, oh, good, let's go schedule some time in the lab and let's work it out. Now, the field guys try it. The people who actually install the systems for a living, they try it, and 90+% of the time, first time we see a device, it comes in and it works, or it works well enough to get the job done. And then maybe there's some little detail to chase down later, but by and large, NMOS, 4 and 5, they're pretty much working in the field as intended, which is to say that a device we haven't seen before or a new software version of some device we saw in the past, the broadcast controller can see it, find it, talk to it, make it go.
Yeah. Early on, there were some vendors that were ahead of the curve. 4 and 5 didn't exist, and they had to come up with their own proprietary mechanisms for doing similar things. And but for the most part, even those folks are now adapting to NMOS because the media nodes are going that direction too. And it works more for a universe where you can have best of breed, and that's what these things are really establishing now is a best of breed universe. By the way, I can see some people were putting questions in the chat. Don't put them in the chat. You got to put them in the Q&A. We can't all see the chat. Put them in the Q&A. That's what we have up, and Tom Morrow will take care of the questions when they're in there.
How do you get dual-homed media nodes? It's an interesting question. You buy them. Grass cameras have dual homing. Sony cameras have dual homing.
Well, that's what Dash 7 is. Dash 7 is essentially two NICs that are set up to receive the multicast from potentially a red and a blue network. Right?
Yeah.
Right. The NICs are at the end of the SFP that you plug two different fibers in for protection and consistency across your entire network.
Yeah, so I guess the answer is you make sure you buy one that has it. If it doesn't, then well, what you can do is what commonly referred to as a purple network. So what you could do is you could feed that to a leaf, and that leaf can then now go up to a red and a blue network. So it's kind of cheating, but for the most of the path, it can take a red and blue path, and then the last leaf of a spine and leaf complex network can then feed your single home device.
Yeah, and examples of that are things like stage monitors, or sometimes even large control room monitors, which have designed in other methodologies to achieve a signal should something fail, but it's pretty unlikely. I mean, somebody's literally like the janitor, no disrespect, can pull a piece of fiber out because it wasn't anchored pretty easily, and you may not know it until, of course, you go on the air and it gets nudged in some other way, and of course it dies. Well, that particular monitor, if it's a single homed monitor, which most monitors are unless they're specifically built for a broadcast application, don't have the ability to switch to something else except maybe an SDI. And a lot of people have still run IP-based converters, or sometimes called throwdown boxes, or strapped to the back of a monitor that will feed the output of that both as an IP signal to an SFP in a monitor and to an SDI spigot, just for safest level of security and protection, which is, there's nothing wrong with that. That's probably a smart use of continued implementations of SDI.
Yeah, absolutely. We haven't talked about essentially gateways, what you're describing there, Karl, but you know, a lot of people are going to have mixed environments. Not everyone can build a greenfield IP environment. There's going to be you know, plenty of SDI or potentially even analog devices out there still, and you know, gateways are your way to get in and out of the IP environment. John, I see you're typing an answer to this one. Do we want to?
Yeah, I'll say what I'm saying, which is when someone asked if how ISO 4 and 5 work with respect to statusing a connection. And so basically ISO 4 is a registry and everything has a timestamp or a version number, but they happen to be times. Then, so when you make a connection, first off, you as a human ask the broadcast controller to connect, like, you know, camera 3 to switcher input 5. Then the broadcast controller knows how to translate those names into what you really meant, which was this video signal and that audio signal, whatever. So ultimately, the broadcast controller does an ISO 5 patch operation to the receiver, you know, like the input of the switcher, and says, take this new signal. The switcher can reject that patch straight out. It can say, you know, yuck, no, or I can't do that, or, you know, there's a variety of the ways it can object to the operation. It can also accept the operation, but then it fails later for some other reason, like it couldn't really parse it, or it has some other resource, you know, some other reason. In either case, what happens is the switcher is responsible for updating its entry in the ISO 4 registry, just the part for that one receiver, and says, you know, I got a new signal, or I've been updated. I got, you know, here's the sender ID of the new signal I'm getting. And then the broadcast controller actually gets notified by the registry. Often the registry lives on the broadcast controller, but they can be separate. So the broadcast controller has like a live linkage to all the registry updates. It sees that receiver update, and then it says, oh, let me just go check and see what all changed on that receiver. So it then reads the current status of it to see, okay, yep, it's getting that signal, which is good because I asked for it. Or if you have multiple broadcast controllers, which you can do, and some people do this for redundancy, some people do it for other reasons, all of the broadcast controllers will actually see that receiver update, and they'll all go figure out why, what updated and translate it back into their own status.
So,
and that's ultimately what lights up the light on the control panel and says, yep, I did that. So in that space of you push the button to when the button lights up and confirms the route, that whole sequence of events happens.
And all of this is literally hidden from 90% of the people in the facility that touch this gear. It's all been engineered to work efficiently and thoroughly all the way down and through to information that goes between broadcast controller and switch fabric. Whereas there's feature sets in most of the enterprise class fabric manufacturers that literally have intelligence to make sure that something like an oversubscription because of too much bandwidth happens, or that path is not available, in which case it even has less sophistication to go out and look for an alternate path, make that path, and then send that information back to the broadcast controller so it updates its database. All of this happens literally in the background, and in most cases no one ever has to touch or deal with it unless there's some other issue involved in that, which is well beyond this discussion, I think.
Exactly. And to visualize it, I think someone who would do a source take in a router control panel is telling the broadcast controller to now make a connection of registered devices that are in ISO 4, connect this source to this destination, and join the multicast from this source to this destination. It's telling it in the standard way.
Yeah, right. But, most people in this industry live above the water line.
Yeah.
And what they see is a routing control system that's got named things, cameras, switcher inputs, all these things. And it's really up to us in the engineering community to deal with the, how that paradigm of named things, now those are really collections of things, video and audio signals and so forth, and a network they have to traverse, and pathfinding in that network, or bandwidth management in that network. So all that stuff that happens between when the finger goes down and the button lights up, that's all what's happening in that little interchange. It's neat, but the vast bulk of the people that we report to don't even want to hear about it. They just like that it works, and that the status, the key is that the status is still meaningful, that button lighting up on the panel still has to mean that a connection got, that a path got built, and that if the input's good, the output will have video.
These are complex systems. There's a comment in the chat from, and rather in the Q&A from someone we know that, these are complex. And what I think these processors are trying to do is to make it look like it always has to operators, right? Mm-hmm. To take the complexity out to the operational point of view. You're not going to get away from the complexity. And yes, the engineers who work here are going to need new skills. This is a very different way of supporting and maintaining and changing, because everybody's facility changes. You're always adding in new facilities, or adding in a new control room or a studio or something. As Karl said, you go beyond the 1151 to 1152, and that these things happen. So, you're going to need to do maintenance and support and expansion and engineering, and there are new tool sets to work on these sorts of things, which we could probably spend a whole meeting talking about the kinds of things that people need to know in the future.
Okay, let me interrupt you and give you a question. The last question from the chat log is, how can I tell if my red-blue networks conform to ST 2110-7 requirements?
It's usually a by design. So the requirements of -7 are really pretty easy. -7 was originally written for long haul networks, where we talk about milliseconds and how many milliseconds of path difference there could be. And then right at the end, as 2110 was getting developed, we said, oh, let's go add another tier that's hundreds of microseconds. But there's so much data flying through these switches, they do not delay the packets. Like there is a little buffer in there, but it's tens of microseconds. It's not hundreds of microseconds. And it's a barely meaningful amount of time in the great scheme of things in these networks. So unless there's, some incredible like geographic distances involved, because you can get quite a few milliseconds worth of fiber between New York and Los Angeles, right? But within a local facility, the delay through the networks is minuscule. And Karl, is that your belief as well? I've never seen a delay-induced problem in a local facility.
No, I haven't heard of it either. It's been evident. I think that part that needs to be understood about the endpoints, as we call them, in a -7 environment, is that there will be two physical NICs in most cases, or SFPs in most cases, on that device. So you need to be sure that if you want to implement a thorough -7 environment, that every device you have understands what -7 is and is physically built that to accommodate that. We have heard of people who have claimed to have a -7 environment, and they'd have insufficient SFPs on the back of the unit. And the claim was, well, that was the intent of the design, which could be taken as an argument or a subject of a different discussion. But basically, you're going to have two fibers that carry exactly the same signals, and the device, the endpoint device, called a receiver in this case, has the sophistication to look at every single packet that enters that system and compare one to the other and pick the choice literally at a packet by packet basis of which signal path, the red or the blue in this case of the example, actually gets to the receiving devices where it's torn apart and reconstructed into something useful to human eyes, for example. So
Yeah, and remember too, -7 comes from the source too. There are two source multicasts that come out, and this doubles the bandwidth of, obviously you have a red and a blue, and they're doing exactly the same thing. So they're doubling the bandwidth of your network.
this actually it's doubled through across two separate networks. That's the kind of the design, to the point that you have two spines, and two of every single leaf that goes to another device is duplicated, and they do a little bit of communication depending upon the provider of the switch amongst themselves to be sure the right paths and things are not terminated or rerouted in ways that the other end device wouldn't see the signal.
Yeah, and to your point, by design, you typically would design the red and blue networks to be pretty architecturally parallel, except for the one example John cited about using an Arista on one side and Cisco on the other. That's not typical design.
No, you make them similar because as an engineer, it will bug you if they're not.
Yeah.
But there's not really a requirement. In fact, we've seen customers, just because of the evolution of their system as they've added things, they'll grow one network and have, extra capacity on it, and then they'll sort of rearrange things a little, and then they'll grow the other side but have extra capacity on it. Like everything, you have to manage the risk and the complexity and the change management as a facility grows. But the good news with the IT stuff is that you can. I mean, that's the biggest thing I've seen in terms of, what's happened in the, let's say, 9 years that this has been happening, right? We started 2110 in VSF now about 9 years ago in 2013. Back then, 10 gig ports were exotic. And a table stakes switch had maybe 48 10 gig ports. And that was like an expensive switch. Now, those are the ones that hold the door open on the machine room. And we've got 100 gig ports or table stakes, 400 are common. And there's, the 800 is exotic. Nobody wants that yet.
It's coming though. 800 will be here.
It is, but it's, but for our purposes, it's exotic just because of failure concentration. You probably don't want, think about how many HD signals are in an 800 gig port. And you really, there's some other issues at play there too. So, but that's really, think about that change. Think about the amount of technological development that happened in that short time. This Moore's Law thing is for real. And, historically, like if you think about cross points back to the analog days, those were borrowed from the telecom industry, right? Those rotary step-by-steps and relay cross points and all that all came from the telecom industry, and then we used it. Other things in television, the line rate equalizers, Sonnet had 1 point, whatever, however many gigabit equalizers for Sonnet, and those got adapted to be the equalizers we use for SDI. Okay, great. All this, we've been borrowing technology from telecom forever.
Absolutely.
Now, their power of two law of technology development has outpaced our kind of, lower powered gamma curve. So we are not, as a television industry, the largest consumer or the highest, sort of requirement consumer of these technologies. The switches, even in the largest broadcast plant, are what the data center guys call medium.
Right. Or the financial security, financial processing people, the Wall Streets of the world.
Yeah, and even these problems we worry about, like change management and deployment and rollback and all that, ask your fellow engineers who work downtown in the finance industry, how do they do that stuff? Because they have ways. And what we are doing as an industry is using a lot of the same tools and processes they use.
Right.
We're just getting over the fact that these are rigorous and require thought.
And we're seeing manufacturers of products now adopt their architectures to address this. It used to be that, back in the early days, a 1 gig connection was unheard of, if at all, in some of these products. And now we have multiple 100 gig connections to, say, a production switcher that's designed to be both UHD and high definition scale. It's not unusual at all for us now to be designing in 100 gig increments to these signal sets, not because you're going to see a necessarily 100 gig data signal going across it, unless you're trying to do high frame rate, slow motions, camera feeds and things like that. That might not be necessarily usual, but it's certainly on the roadmap, and IP allows us to do that. But we are seeing multiple signals which are basically combined to a single piece of fiber that have every single input capable on that production switcher that can run a 1080p 60 type signal to it. And you only have that one particular fiber, well, two if you're doing red and blue architectures. So very, very complex capabilities inside switchers, but and those kinds of devices, multi-viewers is another good example. And they are, quite frankly, commonplace now in design in the facilities that are looking to go IP and have a lot of vision to move forward with capabilities, including UHD further down the road.
Yeah, I remember the first time we had just installed, I think, QVC Japan, and this was a nice diversified project, all UHD, HDR, went live in 2017. And Karl had been there, and I asked him to send, or was one of your guys, I guess, I asked them to send me some pictures because I didn't get to go to Japan to see it. And still sore about that. And as I sent pictures of the front of the rack, looks like normal. But you look at the back of the rack, and it's a completely different world, because like the back of the rack with all the CCUs, it's like, okay, there's these CCUs and they've got power cords and a big SMPTE fiber goes in. And then a little tiny fiber comes out, and that's it. And it's so empty looking without all the SDI cables. And you go behind the switcher and it's the same thing. You go behind an SDI production switcher and it's this rat's nest of this incredibly beautifully tailored, sculpted, hand-laid, hand-tied, beautiful arrangement of SDI cables until somebody modifies one of them.
Right.
And now it's like a couple of fibers. It's the whole back of the rack's empty because of the fibers.
But what does that allow manufacturers to do? Is to build density. And now suddenly you're packing everything into one RU, and your power supplies are 1,000 watts per one RU, and suddenly you can't handle all the power. But we digress.
Well, yeah,
pretty easy to digress with this.
The physical architectures of these facilities really play an important part to how you go about designing. This is not just taking any old plain Jane architect that's done a building before and say, all right, we're going to do an IP infrastructure. Go for it, and you find out that they've never touched a piece of fiber in their life, or at best maybe they've touched it running across the floor somewhere. This is really a new set of capabilities that allow for flexibility and frankly, a lot less cost. You think of the amount of copper that went into a facility, particularly a UHD ready facility, and how much of it gets used in any particular time, and then layer in all of the steel trays and so forth that have to interleave throughout the whole facility to deliver that coax and copper systems. It's incredible how that's changed now. We're literally, instead of 36-inch wide, 8-inch deep steel cable trays, we're now putting in wire baskets to handle the Ethernet copper cable at the most, almost probably a 95% reduction in coax cable. So there is a real plus to this IP infrastructure that we haven't touched on.
Yeah, there's no question. Then to follow up on your bandwidth and things earlier, UHD, remember UHD is beyond 10 gig. So it's 12 gig, you know, at a minimum, not counting high frame rate or HDR, wide color gamut. And, you know, 8K goes even bigger than it. It's 48 gigs. So this, you know, bandwidth's going to add up. So we're going to need those 400 gig ports, you know, at some point.
Mhm.
All right, I want to go back to NMOS and talk through the I want to say the newer ones,
Well,
but
I mean,
these other ones.
Yeah, 4 and 5 were the ones that there was no other thing that did that. So 4 and 5 was definitely, you know, for 2110 to work, there had to be 4 and 5. And that's what got the whole industry marshaled around getting those finished, done, implemented everywhere. Now, ISO 6, I didn't draw here. It was kind of a attempt at building a interface, common API for network managers, or network for the, you know, kind of network switch controllers. But the reality is Cisco had a better API on their own. Arista had a better API on their own. They were different. There was no third vendor at the time that was trying to be in that. And so most of the broadcast controller vendors just said, look, I wrote to the Cisco API and I wrote to the Arista API, and this middle one that neither of them likes, what's the point? That's my opinion, you know, as is everything I say. But
No, you're right, John. And what, you know, we talked about a managed network. Broadcast controller is doing flow management. It's managing the bandwidth of the switch. So it knows that 10 gig port, how many, you know, HD signals are running on it, and when not to saturate that port. Right.
Yeah.
And it does that through, like you said, an API to the network controller portion of the switch. And we're talking about COT switches at this point. We're not talking about any dedicated, you know, broadcast controller and dedicated hardware made by any certain vendor. We're talking COT switches, and how do you talk to those COT switches? And those network controller connections and management are exposed through an API. And that's what the broadcast controllers talk to. There was a question at one point about broadcast controllers and what do they display and all that. And it varies across the map. You know, John, you could probably expose and show and whatnot, but they're all, you know, they're trying to provide you with all the data and the telemetry about your network and what's available and what's not, and what connections are there and what sources are there and all that sort of business.
And frankly, part of that answer to that from a user standpoint, it's really their choice. What do they see as the best thing that they can implement their management and maintenance factors on and feel comfortable with using? That's really the reason why a lot of broadcast controllers might be selected versus another.
yeah, and I think a big part of that too is you know, there's different users within a facility, and they have different wants of what information they really want to see. So a big part of the broadcast controller challenge is not putting too much information in front of the wrong person, right? You know, master control operator, they've just got the main feed, the protect feed. They're going to pick one or the other and write in the notebook why they did it. But the maintenance engineer that gets called when they, you know, after they ring the bell, after they make that choice, they want more information about what and why and all that. And then ultimately the, you know, design engineers want more information than that. And managing, you know, how much information you show in which view and why is a big part of, you know, designing the control systems that go with all this.
Absolutely. All right, let's knock out the rest of these 07, 08, 09, 10, and then we can talk about some common
Okay.
practices and whatnot.
All right, so 7 was, and is, 7 is kind of a work in progress. The idea was event and tally, you know, how do I do tally? But of course, no two people mean the same thing when they say tally. It's kind of funny, you know, is tally tally lamps? Is tally UMDs? Is tally some other thing? So ISO 7 right now defines a low-level mechanism for having flows of messages that go between things. The actual messages that would convey any information are, you know, not so thoroughly defined yet. That's something that actually there needs to be some new activity on to go back and start filling in the blanks of those messages. Part of why there hasn't been a ton of focus on ISO 7, I think, is that honestly, like, you know, in the multi-viewer world, the tally lamps and the UMDs and things, they get filled in by current protocols that are still perfectly applicable, right? So, you know, TSL5 or whichever protocol you like. So the tally systems know how to talk to multi-viewers. We didn't need to invent a new protocol for that to happen. Likewise, for routing and for, you know, tally of names and things, there's already 10 protocols that do that. You know, there's Quartz protocol and Leech protocol and Grass Native and NV9000 and SWPO8. Those protocols all exist. And so there wasn't really a dying industrial need to create one more. So that's kind of, my opinion, why ISO 7 is sort of in that work in progress state, is we've got a way to send messages, but there wasn't a really, like, you know, forcing industrial need to go define a whole message set for that yet.
And if you've got an existing facility already in SDI and you're trying to change that to IP, you probably already have a vendor X's tally management system, which already talks all the various protocols to all the various devices that get signaling or need signaling. They work perfectly fine. There's no absolute reason to have to follow anything that's written for IP in order to get to continue tally. It just still keeps working the way it is. Maybe in the long run, we'll see more driven interest towards getting better improvements in how tally works and change it to an ISO 7 environment. One of the examples might be, how do you go about remote triggering activities that happen in a REMI environment or home management system or hotel room somewhere where you might want to have that tally instances show up as a direct signal versus just seeing it on a monitor, a multi-viewer return or something like that. So lots of reasons to continue that going forward.
So you bring up a point there that I don't think we've touched on, is that typical proprietary systems that exist now are out of band, right? So they were running on a production network or something in parallel to the 2110 network. Some of what we've talked about here, 4, 5, 7, these can run in band. So, you know, on the 2110 network, you can have these signals propagating through, and you don't necessarily need that control network to go around from media node to media node.
True, although it's a little bit of a mix. Like, there's a lot of audio devices that merge together the control and the media network.
Yep.
And in the video world, for whatever historical quirk of reasons, we've tended to keep them separate. So most practical facilities wind up building some amount of unicast routing so that you can reach all these services, you know, tally protocols and other things from either side, from the media network or from the control network.
Yep.
So the unicast routes kind of work regardless, just because there are a bunch of audio devices that are converged already. And in video, some are converged, some can be converged, some will be converged later. But tell you, it's pretty handy to have a separate management network when something goes down.
Oh, no question, no question.
Yep. There's a lot of argument and discussion among facilities we work with as to whether there's an imperative factor that management control must be in band. There's products that already do that, some of the SFP-based products, and even some of the throw-down boxes that you don't necessarily want to attach a fiber and an Ethernet cable to is a good example.
You see Tom's raising his hand. Tom, you want to say something?
Well, we have some questions. John, you were answering, it's actually a multiple question. Did you want to go through that for the entire audience, or you want to do that just through the chat? Chat?
Well, there was one about ISO 5 patching, and it seemed like a level of detail that was probably better just typed at. But
Okay.
it's ISO 5 is the endpoint where you tell a receiver what to do. And what you do is you do it's all done with HTML actually. You do an HTML patch or an HTTP patch operation to an endpoint called staged. And one of the things you can patch is an activation clause that says, and do that. You don't have to, but you can. And you can also say, do that 100 milliseconds from now, or you can say, do that at some future time, although there's dangers of that. But what happens ultimately, there's an active endpoint that's where it shows up after it happens. And so you don't patch to active, you patch to staged, and then the device, after it implements it, transitions it to active.
I think we should make a description for the audience, John, about patch does not mean a physical cable.
Oh, sorry. Patch is a verb. And it has to do, like HTML has put and get. You do gets. Every time you type in a URL, you're doing a get. And if you actually hit, submit on a form, you're doing a put. And then there's a third thing called a patch, which is like a put, but it only has some of the information.
That's where the IT world is now converged with the media world.
Yeah, absolutely.
Yeah. They do call them patch cords, just like we do.
Yeah. There was another question about compressed signals, and 2110 certainly has a carrier mechanism for compressed signals. It's up to really the broadcast controller that's managing the flows and knows what the sources, the media nodes are, on whether they can receive something that's compressed or uncompressed. So, nothing in the network is limiting you from sending the wrong signal to the wrong thing. So you're hopeful that your broadcast controller is going to manage that. You're going to put the onus on the broadcast controller to do that sort of thing. We're certainly looking at doing things like that, routing things like NDI or RIST or SRT or other various compressed formats around in a 2110 network, at least to get in and out. And then you get to things like NATing, which we haven't talked about yet, but coming in from the outside world through leaves and not being directly connected to 2110, but being able to enter signals like this. And you can do transcoding to come in and out, and there are all sorts of things we can get to. So maybe we'll finish.
Tom has his hand up, and it might be because he's doing a time check on us.
Well, that and the fact we do have some questions still. Do we want to continue on with the discussion, or do we want to take questions?
I think I'm just looking at some of these questions. I think we addressed most of them. There's some,
one
best practices.
I think the last one definitely has some merit, that the larger facility for 2110 versus some of the smaller facilities that don't have the capability of handling the level of complexity and don't have the staff to be able to do the engineering on the IT side, broadcast IT side, that they need. So, I think that's an issue that we should cover as well.
Yeah, and no question. And we talked about that a little bit earlier with scale, because a lot of times you make this decision to move to IP mainly because of scale. Certainly, SDI is a very mature technology that works in its sense, and you're not going to save any money going to IP, that's for sure. It's going to cost you probably a significant more amount of money to go in that direction. So I think that's, you got to make that decision as a facility. How much are you going to grow? And, what are all the products still available in SDI? And you could probably build something very inexpensively that way. There's a huge market that'll never have to go to IP, church markets and small facilities and smaller stations and all sorts of things like that. There's no real need to get to the scale that you need in a large facility. But a lot of what we're talking about here are newer, large facilities. Karl's been involved in a number of these things. And, SoFi, the NFL, and other facilities have put in rather large networks. And, they had no choice. They had to go to IP.
I think, at least from our perspective, our company's perspective, We have done very small scale implementations using, quite frankly, small components that you plug into less expensive, less complex switches, which still are considered enterprise grade because you don't want them to be something you went down to Best Buy and picked up on the countertop. You're not going to get away with that one, sorry. But they don't necessarily have the complexity at all. They may be incorporated with its own broadcast controller, which may have its own white box type of implementation from a switch perspective. So I wouldn't be terribly scared at this point about changing your facility as it operates today. It's the long-term issues that you want to be completely aware of, because if you think for some reason you're going to become a production network instead of a television news network, there's some serious thoughts that have to go into this. And to quote one of the people from John's company, the costs of implementing SDI and IP are very closely becoming aligned, if not aligned right now. Some of the labor costs that went into this in the early stages before NMOS was accepted at the levels that it is today included a lot of commissioning time, mainly because a lot of the products were brand new. They hadn't necessarily gone through a tested environment. They were different. They were unfamiliar to people, and even the own staff of the vendors. I'm not speaking about Imagine here, John, but some of the vendors didn't have the sufficient training. They literally were learning some of this on the fly, on the job, and in place. And that added costs to system designs, layouts, and particularly commissioning. That's really been dwindling down, and I think we're going to see less and less of this as more manufacturers make native IP available type products, IP in, IP out, and consider SDI an option. I believe that's on the horizon, if not already happening.
And great points, Karl. And you know, in the early days, there weren't organizations such as the JT&M, Joint Task Force for Network Media, and the VSF that could do testing. And there were plug fests, which both of you guys have been very involved in. And everybody brought their equipment together to make sure it all worked together and created an environment that was not a science experiment when a customer wanted to deploy it.
And that was almost unheard of prior to IP. I kid you not, we've been in environments, lab type environments, where there was over 100 engineers present that produced brand new products, in some cases alpha products. They brought it to a system that had issues and complexities in it that hadn't been resolved because they hadn't been around something of that scale. They walked away with a working product that was shared collaboratively across many vendors and many companies. Most of them all kept what they did to themselves because that was important for product development and other things we can expect. But it was quite a thing to be at, and probably the best way to learn about IP if you hadn't put your hands on it before.
Yeah, I think one big change I've seen in the industry in the past 10 years that's caused by this is really that, 10 years ago, if you asked me, if one of our field guys said, hey, we're having a problem with, yo-yo dying this or that, and we need to get hold of someone there and sort it out, I'd have been really hard put to find an engineer at Yo-Yo Dying to hook them up with. And now, as an industry, because of these events and the various industry groups we're all working together in, all of sort of the CTOs and engineering VPs at all the companies, we all know each other now, and we have each other's email addresses, and we're not afraid to use them. And it's really, within reason. So a lot of problems get resolved before you as an end user ever see them, because we get on top of them on our own time. And that's really helpful for everybody. And it's a big change compared to a few years ago.
And that's a plug too for SMPTE, because these kind of meetings and organizations allow you to meet your colleagues from other places. If you weren't involved in the plug fest, you might know somebody that has, and you can see people here asking intelligent questions.
And there's nothing wrong with any of you that are on this call or your friends and colleagues, short of becoming a SMPTE member, that would stop you from participating in the the weekly or sometimes less often meetings that happen in the standards community. You pay a modest fee to do that, and you can learn a lot by participation, and we encourage it because we don't have enough users that are actively giving feedback except those that are built systems already, in our opinion.
Yeah, as a matter of fact, AMWA recently created a users forum, which is for non-manufacturers and this is free. You do not have to be a member of AMWA to be part of this. And, there's a Slack channel for it. There is some not really scheduled, but occasional meetings where, they're somewhat soliciting input from folks on what problems are. And this can help AMWA in their, development phases on what to focus on. What is something that maybe hasn't been addressed yet, or what is something that needs more addressing, and it's important to get it from folks in the field that are working on these things.
Right. So Joe asked a question in the chat about how can you get an accurate picture of how the flows are behaving, that sort of thing. One thing I'll say is the test equipment's come a long way.
Yep.
Developing this stuff early on when the only implementation you had was your own was difficult, right? But now there's very good test equipment for 2110. Tektronix, Fabrics, Leader, Bridge Tech. Who am I leaving out, Karl? There's a couple others.
I'd add in
Packet Storm. Jack would be annoyed if I didn't say Packet Storm.
Yeah.
There's no shortage of good test equipment for 2110.
Yeah, John, I'd add to that. A lot of what you just spoke about are endpoint tests. So you can look at the endpoint and see how the media node is and all that. Joe's particular company, who was at one point going to be a second part of this meeting, they have a sort of a test equipment that can look, and it has 100 gig interfaces, so it can look at many flows at the same time. So you look at the spine level of your network, really at the in-depth part, and that's what Packet Storm does too. You can blanket a network with flows and formats and saturate and do some real tests.
Yeah,
not just test, but change the environment, such as add and drop packets in a -7 environment, so you can see if your network really is performing the way it should be, that is glitch free, until if for some strange reason both the red and the blue packets or networks drop the same packet, you're going to lose a chunk of it, but for a very short period of time.
Yeah, exactly. And how do people test -7? You can pull cables, you can inject errors, or you can do things that are more intelligent, right? And force errors and see when it switches back and forth. And you can, -7 is amazing, how seamless it is, and how recovery is completely seamless. Really is amazing.
You just use a fiber attenuator. You wrap the fiber around your pencil enough times, it's 1 dB per twist.
Yeah, but as Karl said earlier, you can do this switches at the packet level. So if you can find a way of switching microseconds, much faster than anybody could unplug a patch cord or attenuate fiber.
Yep.
Yeah, considering that a single packet is equivalent to about a very partial level of one single line. You're not going to find that unless your eye catches it or you've recorded it somewhere. It's really important to understand that your network is performing the way it's supposed to, and that your end devices are doing what they're supposed to do.
Yeah. Now, the end devices all count those errors and tell you about them. So there's a ton of telemetry that's available from all the endpoints. And that's something that, I just want to put a plug in about when you have a multi-viewer on the wall and there's a bunch of pips, and most facilities, people walk in, they look up at the wall, all the pips are there, things are good. But now that we have these IP systems with all this redundancy and -7 and all these things, the system will protect a lot of failure modes. And so those multi-viewer pips, they all look great because, even if you've got a lot of failures that have happened, they'll still look great. And that's a problem, because that means that you have to have some other method to know that things have failed. So we have to start paying more attention to the telemetry from devices, logs, things like that tell you, hey, you've got some dribbling packet loss on this link. You've got some, header checksum errors on this link. You know, the network tells you a lot of warning shots before it goes fail.
Yeah, to your example earlier with the switch failed and they didn't know until the one editor flagged that, you know, they didn't have their point there. You need to monitor. And there are plenty of devices and methods to look at doing those sorts of things that come from the greater IT industry as a whole, you know?
Yeah, there's free ones. I mean, there's freeware network monitoring tools that are actually not terrible. I mean, you know, whether you want to run your whole facility on them, I don't know, but you know, there's a lot of things you can play with today that is really learning, right? And even if you aren't doing full on 2110, this, that, like setting up a logger and building a couple of API probes for the things you have a lot of in your plant and gathering some telemetry and looking at trends and data, that's work you can all do today. That's something that I encourage everybody to get in touch with the telemetry from your systems, because ultimately that data is all they're trying to tell you what's going to fail tomorrow.
John, I think it's a timely point to talk about, or at least make the vendors aware that this kind of education is lacking in the industry on a large scale. There aren't YouTube things that you can go necessarily to and get an analysis of which piece of test equipment does what, or how you maybe use that. And maybe that's a worthy thing that we could stress to manufacturers to help us with.
Okay, yeah.
Yeah, absolutely. There are a couple of good questions in the Q&A. There was one that bubbled up and then went away, but I'll take that one, and then maybe John, you want to take the one about ground to cloud and cloud to ground. But there was one about compressed formats and NDI and how you integrate that into a network like we're looking at now. And typically you'll have a parallel network that'll deal with compressed signals, because you don't need to flow manage those signals typically. So, but when you have a 2110 device that needs to consume them, let's say it's an NDI source and you want to consume it in 2110, you typically transcode and then NAT and bring that into your 2110 network. That would be a typical path for doing that. And if you have a savvy broadcast controller, they may be able to control and route that signal through that transcoding device and into your network. That's what we're doing. And that's what I think probably the future of these things are, is that to the user, to the operator, it doesn't matter where or what format that signal is in. You can use your transcode resources to now bring it in and bring it to the 2110 source or destination that you needed to get to. Yes, you have to be careful. It's like tie lines. You have to be careful of consuming all the resources you have, transcode resources and such. But that's a typical way of doing those sorts of things.
And this is going to help
It's
amplify the -21 part of which Mike was describing. -21 has the specifications for how to carry a particular type of compressed signal flow. It was originally started with VC2 or direct by the BBC. That's who promoted and did the work to create -22. I meant to say not -21, -22. And that's been extended now to carry J2K as well as JPEG XS, which is going to help tremendously when we go into the ground to cloud, cloud to ground type of modeling and long-term carriage of 2110 type signals over a WAN.
Yeah, and I just to amplify on Mike's point earlier about, you know, how do you mix NDI and 2110 and all these things? It's a lot like the old days where you had SD and HD and conversion, and you tied together one router with the other, and the routing system knew how to take a path. It's the same exact idea. So think of your NDI island like a router, think of your 2110 island like a router, and there's tie lines between them, and the control system knows how to allocate a tie line and take a thing from one to the other. It's really, you know, we don't have to reinvent the entire wheel every time for everything. These are well-established techniques.
And for those familiar with the AES carriage of audio on the SDI embedded stream, think of what you had to do with Dolby E. As long as you followed certain rules and didn't do the wrong things, Dolby E carried, you know, upwards of 8 channels of audio capability on the same signal flow that prior to that was maybe a PCM only audio signal. Same thought process there.
Mm-hmm. Okay, now Peter asked about 2110 over WAN and ground to cloud. I'll give the shortest explanation ever because I think Peter knows the answer to this question too. But there in the video services forum, there's a working group called 2110 over WAN that, kind of like the name implies, that was the idea. It grew into a little more complicated thing about how do you broker an arm's length transaction between, say, ESPN is carrying a football game and CBS Sports wants a PGAD for that, or a permission to take the feed to do summaries and whatever. And so how do you get those arm's length people to be able to take a feed in IP? Because normally it's done some other way, the way it's done today. And so we worked out all these protocols of, how do you advertise it and how do you accept it and how do you interchange it and what protocols used. And so it was started out with using 2110 as the infrastructure for that. But most of the work that's come out of that is actually on the management plane of how do the two parties, how does the sending party disclose what it is? How does the receiving party, sort of get those details? And both ends use NMOS in a sort of way. I mean, it's just NMOS without a central registry. And it very carefully uses the secure NMOS. See, Mike, we're going to talk about security eventually. So all the NMOS APIs are done with HTTP. And just like your bank secures your credit card transaction, we use those same techniques of TSL and JSON web tokens and so forth to secure the APIs in these, public transaction scenarios. So the secure NMOS is not really widely deployed yet because it has some overheads and challenges and so forth, but it's getting there. And I think that the use of it on public interfaces is going to really drive that because no one's going to use it on a public interface if it's not secure.
Yeah, I think what's not shown on the diagram here, because this is a whole separate meeting, is that this is a facility, a campus.
Yeah.
Diagram here.
We're not showing that was up. You're right.
Yeah. Well, it's good. No, go back. Keep it there for a second because I want to finish the point. Is that if you the eventual is the outcome of this and the evolution is moving to cloud environments, right? And everybody goes to NAB or New York NAB, and you see a demo in the, let's say, the AWS booth or something, and here we are, everything's spun up in the cloud, and here's everything you can do. It's in a cloud instance. Well, how do you get there? And I think that's what that group, cloud to ground to cloud, talks about, is how you now move through secure connections and establish, the eventual cloud environment as an extension of your on-campus, your on-premise environment. How does it look seamless? And that's what NMOS and these other, things we're talking about here will help you establish that securely.
Yeah, and that's really the thing is at some point, there's a responsibility domain and then there's an arm's length transaction. And so if you think about a facility, within a facility, there's an engineering team, they're responsible. It's a localized domain. Then there's a, arm's length transaction when you hand a signal to, your counterpart in Los Angeles. This is a kind of an arm's length transaction, even if it's one company, because you just have to bracket the failure zones and say, look, New York is New York, LA is LA. The same thing happens with the cloud, that you really need to have some, blanketing of that, bracketing of the, zones of that transaction and where the trust boundaries are. The other half of Peter's question about ground to cloud working group is the same angle from the other side, looking at what are the signal interchange points and what are the interop points, both going from ground to cloud, where largely it's this 2110 over WAN activity has worked that question. And then between instances within a cloud, if you're using something like Amazon CDI, how do you describe the flow that you're sending? How does the receiver know what it's getting? How do you do the NMOS equivalent, which is actually going to be NMOS extended this way within the cloud? So that's what we're working on in that group. And it's every other Thursday at 11, in case you want to join us.
Yeah, we just started to touch on security, but
Probably it's 8:35. We should probably
Do you want to go
contemplate
there or do you want to skip it? What do you want to do, John?
Up to you.
I think it's just worth mentioning that, a lot of what manufacturers, vendors have developed up until the last year or two didn't take security into account. And the fact that these might go over WAN environments and extend to the cloud. And, we've seen, passwords in the clear, all sorts of methods used that are not secure. But there's a recognition of this. The EBU recognized it early on. They built what's famously known as the pyramid of security and how to address these things. AMWA's adopted that as IS-10. And, vendors are slowly, and some more than others, starting to look at how to deploy this and how to put this. And it's not simple, right? And there are best practices out there, use of certificates, a number of the other methods that John just described earlier. How do you do that? Which means you have to manage things like certificates. You have to do these sorts of things and put them in there. How do you establish zero trust? How do you create, /31 networks everywhere? So, it's not, you don't have the ability to get to anywhere else unless, your controllers allow you to do this. So it's, there's a whole security ecosystem that we could spend 2 hours talking about.
Plus the fact that there's corporate security involved in a lot of this now. So you may find certain multicast or other addresses that are out of bounds because that practice violates some other security procedure that was established long before 2110 came along. So
yeah.
Although I will say that that's why, as we've secured these APIs and things, we've been really insistent on doing it in a way that's consistent with how the rest of the IT industry does it. So there's nothing we've done in, say, securing the NMOS APIs that's new or unique or novel. It's using TLS and all the approved ciphers. It's using HTTPS. It's using it in the normal way with the normal, JWTs and authentication servers. We were really conspicuous to not invent any television-specific twist on it.
Absolutely. Absolutely. And that's key with everything you see here.
Yeah, because otherwise, you start talking to your corporate CIO and he doesn't want to hear about it unless it's the normal way.
right.
As soon as you go beyond the campus, suddenly, you're connecting to this. Where are you putting the firewalls? Where are you doing this? Where are you doing that?
Right. And it's your point about zero trust is really super important because that's the current way. You in any large enterprise, you have to build some internal boundaries. You can't just rely on there being an external firewall. And even in the zones, most of the zones of those internal boundaries, you can't really, just trust a machine. You have to have secure environments and, 2FA and all that. I mean, in our company, there's 2FA on every service that can do anything.
Two-factor authentication, which is
two-factor authentication. Yeah.
But going back to the point you made earlier, broadcasters and for decades, we air gapped everything. There was no connection to the outside, and we also didn't typically upgrade things. Right? We found a stable platform. The last thing we wanted to do was patch it or change it. Change was an anathema. No one wanted to do that. That was the last thing anyone wanted to do was update it. Well, now you have to. Security patches are constantly being deployed. And the first thing, quite often when you call a vendor for a support issue, the first thing they'll ask you is, what version are you at? And if you're not at the version that they're supporting at the moment, well, call us back when you are. And, so you have to you got to keep up. You got to patch and you got to keep doing these things. So it's, and security wise, you should be anyway.
Yeah, you can complain about bugs, but we do fix them. And then you don't install the update. What do you know about that?
Yeah, stop complaining.
Wow. So yeah, it's, these are all like, motherhood and apple pie things, but we have to really do them. And it's not, in a lot of cases, it's not optional anymore. You want to be on current firmware because that's what's tested against other things. The security patches are real. Over Christmas, there was which one was it? There was some Java JLog or Log4j patch that everyone had to go scramble around and scrub their product and say, oh, log4j, no, we don't use that. But, you know, it was really, you know, and this happens now about every 3 or 4 months. There's some, you know, red hot nuclear, oh, somebody discovered this bug or this, you know, and they're not like bugs in a product, they're bugs in libraries and facilities that are widely used by everybody.
Yeah. Or in the OS.
Yeah, in the OS or in libraries that are
Yeah.
public libraries.
That's right.
Yeah. You know, open source software is great, but when it has a bug, you find out how many people use that same library, and the answer is everybody.
A couple more questions here. Peter had a follow-up. Roadmaps beyond IS-10. What's coming beyond? Maybe a view into. You know, it sounds like we ought to have a separate meeting where we have Brad get up here and just talk about all the you know, things that are coming next and everything AMWA's
Or,
doing.
you know,
Kind of doing his
as-
job from here.
Yeah, or as board members, we'll just put in our plug. You know, AMWA is pretty low cost to join as an end user.
Yeah.
And I think you can join the user group for free.
Yes, absolutely right.
Yeah.
And so if you hit this URL, specs.amwa.tv.com or .nmos or / whatever, it's in the corner there. All the AMWA specs are there. Well, all the NMOS specs are there, and the other specs are in another branch. And, you know, there's a lot of stuff going on. There's a lot of work in progress. There's, you know, we tend to put up drafts of things as opposed to waiting until it's 100% finished before we put it up on the website, because we want public comment. SMPTE is actually doing the same thing in terms of they have what's called a public committee draft process. So now for new things like the PICs, the protocol interoperability check sheets for 2110, they're actually putting those up on GitHub and encouraging people to go look at them before the FCD ballot, you know, before they go to become final.
John, there's also on the AMWA site, there are listings of what's going on, whether they're work in process or and very descriptive explanations that aren't code level type things, although you can find that as well. But users that are interested in what these mean and where we're going on this, a lot of that information is very open and exposed.
Yeah,
Exactly. And versions of this, early versions are published on Git. You know, and if you're a developer and you want to try some of this out, it's there for you to try out. You know, it's very open.
Look at the AMWA repo on GitHub. All this stuff's there. Even the current versions, they're actually the working, you know, the current master branch is on GitHub, and there's tagged, you know, there's tagged versions that correspond to all the different publications. See, Mark Rushton asked about 2110 and SDP files and NMOS. So it's a very simple relationship. The SDP file that's described in 2110 is what you patch to the staged branch in order to activate a connection. So it's no more complicated than that. There's in NMOS, there's a thing called the transport file, which is just someone else's name for an SDP. So you
let's just define an SDP
there.
Let's define SDP for everybody.
Sorry.
Yeah,
So
let's just define
the SDP is defined in RFC 4566. Mike, just look it up. No,
Feeding it to you, John. Feeding it to you.
I know. Oh, wow. No, the SDP is this little text blob, plain text, that is all the defining information for a stream. So, and they exist for transport streams and everything else, but we use them in 2110 to say, you know, is it SDR, is it HDR, how many pixels across, how high, what frame rate, all that kind of stuff is buried in this little text file called an SDP that also says it's video and says whether it's JPEG XS or whether it's RAW or whether it's, you know, MPEG-2 or H.264 or, you know, a million different media types. And these are all defined by the IETF. The whole structure of the SDP and all the, you know, tags that can be in it are more or less defined by the IETF. And so like the SMPTE things like 2110 are actually registered in the big IETF database, or supposed to be anyway. I got to check if we really did, but supposed to be.
Yeah, I'll put a plug in for Wes Simpson. I don't know if he's on the call or not, but he's certainly a member of the New York board. he does a lot of the SMPTE classes, and you probably get those emails, but they're phenomenal. And he goes the description of what John said in human language, so you can understand it. And he's not that John didn't use human language, but we've had him in to do corporate level for groups of people, and I encourage you to take some of Wes's classes. He's really good at describing how all this stuff works.
I don't know if we mentioned it, but SDP stands for Session Description Protocol.
Yep, that's the decoder ring, yes.
Right.
There you go.
And which is funny because it's not a protocol, but it is a session description. So.
Yeah, there we go.
All right, so
We're getting near the end here because my wine glass is almost empty. So
yeah, mine failed a while ago.
No, yeah,
Karl's
it's a
hiding
requirement
his.
for this group.
Okay, we have another question. With concerns on the closer that these devices get to network appliances, the more the human interface is going to change to look like network appliances. What's the response in the IP rooted designers users?
Let me answer that as an operator and a user, and
Yeah,
maybe other guys can chime in too. But I think what we have in the broadcast industry are tried and true interfaces that have been developed over decades. And those things are still present and are presented to the operators because, they've come up with specific operating modes to work in on-air environments typically. So there's no real big desire for manufacturers that create devices such as production switchers and cameras and editing systems and graphics deployment devices to change that. The boxes that sit in the room, yeah, they look like network appliances. They all look like servers now, and that's what kind of they are. But the interfaces that are presented to the operators typically stay the same, and they should be staying the same. Yeah, the management interfaces and the configuration interface is very different, but the operator interfaces should hopefully stay the same.
Right,
Yeah.
or at least they evolve as the job evolves.
Yeah,
I mean,
yeah.
if you think about, we ask operators now to do a lot more than we asked them to do 10 years ago. And we ask, one person to cover off on graphics and this and that and the other thing. And so the interfaces that we give them are evolving to be more multifunctional, a lot more like a web browser than they used to be, a lot more, tabs are very hip and trendy. But it is a challenge because the people who go to college and major in user interface design, they do like to make very trendy user interfaces. And it's, as a product manager, it's often a challenge internally to sort of push back on them and say, hey, I know that this, that's a very trendy way to do that, but we got a whole user base of people who actually like hotkeys and like to be able to feel their keyboard and hit this key and that key and have things happen. And I'll never forget Joe Sig from NEP said famously once, at least in a meeting I was at, I think he actually shouted it, that every time he has to lift his hand off the keyboard and go over and reach for his mouse, an angel dies. And I don't know if that's true, but the sentiment is certainly there that, if you watch power users of systems like, automation systems or editors especially, you look how fast they are as long as they don't have to take their hands off the keyboard versus if they have to reach for a mouse. It's a real thing, right? And so it is an issue, but it's a,
You're going to find more
issue that
changes
we can do.
in the next Windows release than you are going to deal with the typical broadcast equipment orientation.
Yeah.
Think of the first video servers that came out. The operating panel looked just like a tape machine, right?
Right, but that was on purpose.
Yeah, exactly, because you had to keep that same interface on it.
And it spoke Sony protocol over that 9-pin connection.
Exactly.
And it's not just the human interfaces, the tally and routing protocols and all these other things are all these legacy interfaces. And like when we have to list in our product manual, all the protocols and how they're secured, we have to list all these protocols we speak that are not secured because they've never been secured because they were invented in the 70s and we use them over TCP sockets now instead of serial ports. And that's, what's the alternative? don't use that protocol. Oh, but I have to use that protocol. Okay, now we're at least having a conversation.
You know, it's great that you as a manufacturer will state all those protocols that you support. But we find that, you know, when you ask vendors and manufacturers, not just what protocols, but what ports, what, you know, aspects of the IT environment are exposed and what are you using? And quite often they don't do that because it's very, you go back to security, it's very important to know everything that's being used, you know, and make sure, you know, Telnet isn't still open or, you know, they're doing FTP, you know, we try to stop anyone doing anything with FTP and that sort of business. So these are all, you know, best practice IT things.
Yeah, Mike is going to get discovered anyway.
Yeah, but exactly. We're gonna find out anyway when we
Open the kimono and go for it.
Yeah. Exactly. Just let us know ahead of time.
Yeah, and you know, if there are devices that are reliant on these protocols, you just have to design your network such that those are in an isolated area that's firewalled off and whatever, because, you know, as you should have years ago, but nobody thought about it back then.
But if you go back to things like Tally, I mean, that light on the camera so the talent knows where to look, that's never going to change. So you got to find a way to light that Tally no matter how it gets there, whether it's through a GPI or you know, through NMOS, through your IP interface.
Yeah.
Particularly the user acceptance of just take Tally and UMDs. Red and yellow displays are there for particular reasons because the industry wanted it. And I fully expect that as time goes on, the industry is going to start putting demands on IP capabilities, and we hope they do, because that will just prove the fact that this was a more extensible development than just building another SDI type plant.
Yeah, but on the other hand, those Tally lamps right now in every facility, they're lit up using TSL5 protocol over IP. And it works. It works
Yep.
fine. And it can say amber and it can say red and it can say, you know, it can't say make the background color of the UMD be blue. You know, there's like a few things it doesn't do because it's a simple protocol, but it's, you know, there's existing IP protocols that do all that. And the only gripe you really could have about them is they're a little simplistic and maybe they're a little, you know, not secured in a standard way, but those are fixable things without reinventing the universe.
Yep. And these things work and you don't have to throw them out. You can keep those systems in place.
Yeah.
All right. Well, we're getting close to the end here. Ed earlier on said, well, we're going to stop by 9. I didn't think we'd get to 9, but we're pretty close to 9. So.
Yep. How has remote and distributed affected collaboration the way engineers and creative people do their jobs? I'm gonna let Mike talk to that one.
No, that's right.
Joe's question there.
In the chat.
Distributed. Oh, I see.
They never get along
About
anyway.
using the Q&A.
You know, I don't think it has. I mean, I think these established, you know, methods of operating haven't changed when you move to IP. I mean, the operators don't care. You know, they're working the same way they are, and it's our job to make it transparent, frankly. What, you know, a whole separate topic is what IP has enabled is a lot of these work from home technologies. I mean, we wouldn't have gotten through the pandemic if we didn't have a lot of IP interfaces and the ability to control and get to our infrastructure and be able to take those signals and send them to the home. And using things like, you know, AWS as a path, a secure path to get into your building, to get into your infrastructure. You know, we talked about infrastructure and, you know, eventually moving to the cloud, but we found ways to get to the infrastructure that's on premise, you know, through, you know, secure IP environments to get there. And that just, you know, becomes more extensible. And, you know, I think it's changed environments. You know, where you build a new building, you have to accommodate the fact that many people may work outside the building and may work in the building sometimes and outside the building sometimes, and they want to have the same working environment. You know, they want their home set up to be the same as their setup in the building. So I think that's probably the biggest thing. I wouldn't put 2110 there to make that change. I'd say just IP as a mechanism. All right, we're going to close on that.
Yeah, why not?
I think it was a good point.
Any last comments before we go?
I'll say don't conflate IP and 2110. Like to Mike's point, the revolution of how we're using IP networks to do everything in television now is well beyond just 2110. 2110 is useful for a certain domain of use, but the fact that VPNs and IP networking is what's held the whole industry together for the past 2 years is well beyond that. It's a whole set of IT industry technologies that worked for us in the pandemic because they were available, because they had already been developed for many other industries. People were working from home before the pandemic. This just forced us to try and do a lot of this stuff that we thought we had to drive to the office to do it from home. And
did it
the
really
experiment's
fast.
been pretty successful for a lot of things.
Absolutely.
Yeah.
Carl, did you have the last point there?
No, I just was going to say it had happened very fast.
Oh yeah, over a weekend for many of us. All right, I think we're good. Ed, you want any closing remarks? We will get this posted at some point. We'll send out a summary to the journal, which I always complain when the other producers don't do it, so I'll make sure I do it myself. Get that out there, and hopefully this will be packaged up so other folks can see it.
Yes, we'll get this posted on YouTube, the video from this. And I want to thank all of you for a very fine presentation. And I want to wish you a very good evening.
Great. Thanks all.
All right.
Night.
Thank you.
Thanks for
Thanks,
attending.
everyone.
Good night.
Yeah. Bye-bye.